So we select the nodes, 19 and 20 it says in there. And then I need to say, I believe I need to click on add, and then select the nodes, and then click on OK. No, I need to add this. There we go. So we have all these guys. Click on OK, and then click on apply, and then we're fine. You see a very small error in there could give us a lot of trouble. So in here we have this simple supported beam. Now we need to create the loads. So in here, create displacement. I'm gonna create the forces, and I'm gonna say, okay, I need to give a set of forces a name called forces 1 for the set forces. And then I need to go and say there was no data for input load VC set. Sorry, we need to go inputting over here. And then the force is going to be in the minus y direction for some of these nodes. So I need to apply this is 0 in the x direction, minus 1000 in the negative direction, and then this is going to be 0 here, and at the same time the moments I'm going to enter them as zeros, and I say OK, click on OK. And now we need to go to the application region. I would select this node, see, like this, and selecting those nodes. Click on OK. Select on the application region. Oh, I think I already did. And then I need to say on apply. I wish this application say yes, and there you have. So I having now a beam that has a simple supported beam in the actually, no, this is a fixed beam. I fixed those nodes, not simple supported, but because simple supported would allow motion on one direction, not on the y direction. But in this case, we just fixed them, which is fine. I mean, we have a beam that has two ends fixed, and it has loads in the middle. Okay. So what next? We done the meshing, we did the loads. We need to do the properties. Okay. I think we need to define an isotropic material first. Create isotropic, manual input, material name. I think I called it the steel last time. Okay, so this is steel there. And then I need to do what properties does it have? Modulus of elasticity, we put it was like 30 E6 like this, and the Poisson ratio is 0.25 like that. Shear modulus, I don't think we need to enter this because usually it's 1/2 of the other. So I think for what we're doing, we are fine. And then temperature, I'll say OK, I'll click on OK. I don't think we need to change anything with the linear static material. We say OK, fine. Click on apply. Always click on apply so that you know what we're doing. Now here, remember we did steel, but I did with 3 E's. Well, that's fine. We need the properties of the elements. So we need to create the properties of the elements. This was the materials. So now we need to create the so this materials. Okay. We check the analysis code in the Nastran, type structural. We click on OK. And we need the properties in there. To the properties, I guess. Create 2D properties. We need the input properties. Here we have to tell the material name. Steel with 3 E's. That was what we had. Orientation. It's isotropic.
Professor?
Yeah.
I think you can actually select the material, the material that you created if you click on the map problem name.
Where? Here?
But a little bit to the right on that square.
Yeah.
And then you select.
Thank you. Then we select it in there and we say OK. And now we need to do the application region, because this is what we just did. The properties. Select the application region. I feel comfortable with just doing this. And I click like that, do the whole surface there. Select entities. Yeah, the entities, and then we say click on OK and click on apply. Yep. What element properties need to be entered to continue? Oh, the set we did not do. You see, that's the problem. Well, okay. This is a little mess up in here. Property set name. I have to say property. Okay, so that's our property set. Must be entered in here, and then we have input properties. We have the material, which is fine. Then select the application region. We're going to say surface here. And then we're going to say fine, okay. And I believe we need to say on apply. Yes. The thickness is required. We didn't do that. So we need to, I think it's probably here. Yeah, see here? I would say thickness, let's give it a 2. How is that? So now we have the property name, we have the thickness, select the application region, we select the application region there and we say OK, and then you click on apply, and then you say OK. And finally it accepted my properties. So now we have done geometry, properties, laws and boundary condition. Meshing, we go to analysis. Yes?
I'm lost. From the first one, I couldn't get the supports. It goes on the whole corner.
Have to back up a little. Okay, we need to do the analysis now. So we're using on the analysis tab, we analyze the model, full run, and then we specify the subcases in here. We call it case 1, and we specify case 1. And we click on apply and you say okay, fine, and then we go onto this region. When we click on apply, we go to the we submit the job to Nastran, and then goes and finish it up doing the calculations. And then while we are here, we need to go to access the results. So we go access results. This XTV, they are the files that contain the results. So you select the results file. Hopefully everything went fine, and we have a results file in here. It's called Beam, simple supported Beam results, and you say OK, and then you click on apply, and then we go over here to results, and we are lucky that we have all the displacement, for example, translational displacements, and we want to see those results, and then we are going to say apply, and lo and behold, we have our results that we have done for this month. So it makes sense that the displacement is in the middle is higher, but you could actually maybe animate this a little bit, and you will see the changing of the model. But it also would be nice to see the see other kind of results, like stresses, for example, principal stress. Click on apply. Let's do the animation. I think we're gonna have to stop, pause animation. In here we're gonna go, don't animate this, but the translational, and then you see how the beam deforms. So you can see the beam deflection, and this is this translational displacement, and then the stress. There's several results using the stress and the displacement. The translational displacement, that's you could display several of these. See. You could play around with all these results in here. Stress tensor maybe, and then we have this translational displacements, and that way you can see I think these are important here. And do the stress analysis, principal stress. There you go. That illustrates from beginning to end this demonstration of a simple supported beam. Actually, it's fixed on nodes and loaded in the middle.